Today we are going to discuss reactions due to alpha hydrogens. So let's read from the book. Acidity of alpha hydrogens of aldehyde and ketone. Aldehyde and ketones undergo a number of reactions due to acidic nature of alpha hydrogen. The acidity of alpha hydrogens of carbonyl compound is due to strong electron withdrawing effect of carbonyl group and resonance stabilization of the conjugate base. Now let's try to understand why the alpha hydrogens are acidic in case of carbonyl compound. So let's draw carbonyl compound. So this is carbonyl functional group, and the carbon to which it is bonded is called alpha carbon. So this carbon is the alpha carbon, and hydrogen bonded to alpha carbon is the alpha hydrogen. When this alpha hydrogen get abstracted by base, so base can be any negative ion. When this base abstract the alpha hydrogen in the form of H plus ion, bonding electrons will move at alpha carbon. So here you will get the structure. This is the carbonyl carbon. Now this alpha carbon will carry negative charge. This negative charge will get stabilized by the resonance of carbonyl carbon. So this negative charge will move between these two carbons, and the pi bond will move at oxygen. So here you will get the next resonating structure. In this resonating structure, oxygen carries negative charge, and double bond is formed between these two carbons. So that's how negative charge gets stabilized by the resonance effect. That's why alpha hydrogens are acidic in carbonyl compounds. Now let's read from the book. First reaction is Aldol condensation. Aldehyde and ketones having at least one alpha hydrogen undergo a reaction in presence of dilute alkali as a catalyst to form beta hydroxyaldehyde, which is also called as aldol, or beta hydroxy ketone, also named as ketol, respectively. This is known as Aldol reaction. So in Aldol reaction, first requirement is the presence of at least one alpha hydrogen, and in presence of dilute alkali, aldehyde or ketone undergo Aldol reaction, which results in the formation of beta hydroxyaldehyde. Now let's try to understand how this reaction takes place. Now let's draw the structure of ethanol. Ethanol has two carbons. So this is CH3, C double bond O, H. This is the aldehyde functional group, and the carbon to which aldehyde functional group is bonded is called alpha carbon, and the hydrogens bonded to alpha carbon are the alpha hydrogens. So when it react with base dilute alkali, here dilute alkali is NaOH. So this dilute alkali will abstract one of the alpha hydrogen from the aldehyde molecule, and here it results in the formation of CH2, C double bond O, H. As this base abstracted one of the alpha hydrogen, negative charge will develop at alpha carbon. So this carbon is the alpha carbon, and negative charge will develop at this alpha carbon. Now this aldehyde will act as a nucleophile, and another molecule of aldehyde will serve as an electrophile. So when this nucleophile react with another molecule of aldehyde, now I am going to draw the another molecule of aldehyde with the different color. So this is the another molecule of aldehyde, C double bond O, H. This is aldehyde functional group, and this is the ethanol. So here I am going to write CH. This carbonyl carbon is electron deficient carbon, as it is bonded to electronegative oxygen. This electron deficient carbon will serve as an electrophile, and the another molecule of aldehyde will act as a nucleophile. So it will attack on this carbonyl carbon, and the pi bond will move to oxygen. Now write down the product of this reaction. So this is C double bond O, H. This is aldehyde functional group, and this CH2 will attack on this carbonyl carbon. So this is carbon, and here it is bonded to oxygen. Now negative charge will develop at oxygen, and this carbonyl carbon is bonded to one of the hydrogen and CH3. Now this negatively charged oxygen will abstract proton from the reaction medium. As it abstracted proton from the reaction medium, now write down the product H, C double bond O, C. Here there are two hydrogens and it is bonded to C. Here this oxygen abstracted hydrogen from the reaction medium, so now it will become OH. It is bonded to one of the hydrogen and here CH3. So here this is the aldehyde functional group, and the carbon to which aldehyde functional group is bonded is called alpha carbon, and carbon next to it is the beta carbon. So now you will get beta hydroxy aldehyde. As this molecule contains two functional groups, one functional group is the aldehyde functional group and the another functional group is the OH hydroxy functional group. That's why the name of this molecule is Aldol. ALD for aldehyde and OL for hydroxy functional group. That's how the name aldol comes from. When this aldol undergo condensation, means when you remove water molecule from this aldol. So when you remove water molecule from this aldol, you have to remove OH from the beta carbon and H from the alpha carbon. So here you will get the product. This is C, H double bond O, and here this carbon loses one of the hydrogen, so it will has just one hydrogen, and now double bond will be formed between these two carbons, and here you will get carbon. It is bonded to one side with CH3 and the another side with H. Now again this is the aldehyde functional group, and the carbon to which it is bonded is the alpha carbon and the carbon next to it is the beta carbon. So here you will get alpha beta unsaturated aldehyde. This is the product of aldol condensation, and this is the aldol product. Now let's see in the reaction. Here there are two molecules of ethanol. When they react in presence of dilute NaOH, it gives aldol. This is 3-hydroxybutanol. Count the number of carbon: 1, 2, 3 and 4. There are 4 carbons and hydroxy group is bonded to third carbon. So the name of this molecule will be 3-hydroxy. As it contains 4 carbons, so the name parent name will be butane. As it contains aldehyde functional group, suffix will be butanol. And here when you remove water molecule from the aldol product, you will get aldol condensation product, and this is but2-enol. As it contains double bond, for double bond ene is there and ul is for the aldehyde. So the name of aldol condensation product is but2-enol. Similarly, you can write the reaction with the ketone. So let's try to write the reaction with propanone. First of all, draw the structure of propanone. This is CH3, C double bond O, CH3. There are 2 alpha carbon. This is also alpha carbon. So here this is the ketone functional group, and the carbon to which it is bonded is called the alpha carbon. So there are 2 alpha carbon. When it reacts with dilute alkali, dilute alkali can remove either of the alpha hydrogen. So here you will get CH3, C double bond O, CH2, and the negative charge will develop at this alpha carbon. Now this molecule will act as a nucleophile, and the another molecule of ketone will act as a electrophile. Now let's draw the another molecule of ketone with a different color. So this is CH3, C double bond O, CH3. Now we know the carbonyl carbon is electron deficient carbon. So this nucleophile will attack on the carbonyl carbon, and pi electron will move to the oxygen. So here you will get the product. Now write down the product. C double bond O, as it is bonded to one side with the CH3, CH2 will get attached to the carbonyl carbon of the another molecule. So this is carbonyl carbon. It is bonded to oxygen. This oxygen will develop negative charge. And this carbonyl carbon is already bonded to two CH3 groups. Now when this molecule abstract H plus from the reaction medium, you will get product of aldol reaction. CH3, C double bond O, CH2, C, OH, CH3 and CH3. So this is beta hydroxy ketone. This is beta hydroxy ketone or ketol, as it contains ketone functional group and hydroxy functional group. So ket for ketone and OL for hydroxy functional group. Now write the IUPAC name of this molecule. First of all, count the number of carbons present in the longest carbon chain. So when you start numbering from here, 1, 2, 3, 4 and 5. So there are 5 carbons in the parent chain. OH group is bonded to 4th carbon and there is one methyl substituent which is also bonded to 4th carbon. So the name of this molecule will be 4-hydroxy 4-methyl pentane 2-one. Now when you remove water molecule from this ketol, so after the removal of water molecule, OH will be removed from the beta carbon and H will be removed from the alpha carbon. So first of all, identify alpha and beta carbon. This is the ketone functional group and the carbon to which this ketone functional group is bonded is called the alpha carbon and carbon next to it is the beta carbon. So you have to remove OH from this beta carbon and H from this alpha carbon. So here you will get the product. This is CH3, C double bond O. Here you have to remove hydrogen from this alpha carbon. So this alpha carbon will left with just one hydrogen. Now double bond will be formed between 3rd and 4th carbon and here it is bonded to carbon and this carbon is bonded with 2 CH3 groups. Now write down the name of this molecule. First of all, select the longest carbon chain that contains both the functional group. 5 carbon long chain which contains double bond as well as ketone functional group. Now number the chain. You will start numbering from here 1, 2, 3, 4 and this is 5. Here double bond is between 3rd and 4th carbon and there is one methyl substituent bonded to 4th carbon. So the name of this molecule will be 4-methyl. Parent is 5 carbon long, so the parent will be pent and double bond starts from 3rd carbon. So here you will write 3-ene and ketone is at 2nd position. So here you will write 2-one. So this is the aldol condensation product in which double bond is formed between alpha and beta carbon. So this is alpha beta unsaturated ketone. So this is alpha beta unsaturated ketone, which is the product of aldol condensation. Now let's read from the book. The name aldol is derived from names of two functional groups, aldehyde and alcohol, present in the product. The aldol and ketol readily lose water to give alpha beta unsaturated carbonyl compounds, which are aldol condensation products, and the reaction is called aldol condensation. Though the ketones gives ketols, compound containing keto and alcohol groups, the general name aldol condensation still applies to the reaction of ketone due to their similarity with the aldehyde. Now come to the second type of reaction, is cross aldol condensation. When aldol condensation is carried out between two different aldehydes or two different ketones, it is called cross aldol condensation. If both of them contain alpha hydrogen, it gives a mixture of 4 products. This is illustrated by the Aldol reaction of mixture of ethanal and propanal. So let's try to figure out how to get 4 different products by the reaction of ethanal and propanal. So there is a short trick to get the product of aldol condensation. So when reaction takes place with one molecule of ethanal and propanal, so this is CH3, C double bond OH, this is ethanal, and here this is propanal, CH3, CH2, C double bond OH, this is propanal. So when they react, ethanal can react with itself also and propanal can react with itself also. So here you will get the one product which is self-condensation product, and here also you will get self-condensation product. So here that's how you will get 2 self-condensation product. But when they react with each other, you will get 2 different products, because once ethanal will act as a nucleophile and propanal will act as a electrophile. In the another condition, when ethanal act as a electrophile and when propanal act as a nucleophile. So that's how you will get 4 different products. So let's try to find out how to write these 4 different products without writing the detailed mechanism. First of all, try to understand it with the simplest example of ethanol. So let's draw the structure of ethanol in this way. So here this is the carbonyl carbon and it is bonded with one of the hydrogen and one with the CH3. Now draw the structure of another molecule of ethanol. So this is CH3, but I am going to expand the structure of CH3. Now this is bonded with aldehyde functional group. So here this is C double bond OH. Now remove the water molecule, O from one of the carbonyl and 2 hydrogens from the alpha carbon. So now that's how you have to remove 2 hydrogens from the alpha carbon of the another molecule. This is the alpha carbon of the another molecule and this is the carbonyl oxygen of one of the molecule. Now write down the product of this reaction by joining rest of the structure. So here you will get CH3C, this is bonded with H, and here you will get the double bond. This is the double bond. Now write this part of the structure. So this is C, H, single bond C, double bond O, H. So here this is the aldehyde functional group and the carbon to which it is bonded is the alpha carbon and carbon next to it is the beta carbon. So this is alpha beta unsaturated aldehyde. This is the aldol condensation product of self condensation of ethanol. Similarly, you can write the product of self condensation of propanal. So let's draw the structure of propanal in the same way. This is the carbonyl functional group. One side it is bonded with hydrogen and on the other side it is bonded with CH2, CH3. So this is propanal. Now draw the structure of another molecule of propanal facing alpha hydrogens towards this molecule. We have to write CH2. One side it is bonded with CH3 and the other side it is bonded with C double bond OH. So this is the alpha carbon and there are 2 alpha hydrogens. So you just have to remove one of the oxygen from here and 2 hydrogens from this alpha carbon. Now write down the product by joining these molecules. So here you will get C, H. One side it is bonded with CH2, CH3. Now double bond will be formed between these 2 carbons. Now write down rest of the structure. C, it is bonded with CH3 and here it is C double bond OH. So this is the alpha carbon and this is the beta carbon. So that's how you will get the aldol condensation product of self condensation of propanal, which is alpha beta unsaturated aldehyde. So this is the first product, this is second product Now write down the product of cross aldol condensation. So here, first of all, draw the structure of ethanal. So this is carbonyl functional group. One side it is bonded with H and on the other side it is bonded with CH3. Now draw the structure of propanal, facing alpha hydrogens towards this side. CH2, here it is bonded with C double bond OH and this is bonded with CH3. So this is the alpha carbon. Now you have to remove oxygen from ethanol and alpha hydrogen from propanal. Now join the structure. So here you will get CH, single bond CH3. Double bond will be formed between these two carbons. And draw the remaining structure. This is carbon. Here it is bonded with CH3 and the another side it is bonded with C double bond OH. So this is alpha beta unsaturated aldehyde. So this is the third product. Now draw the fourth product. Now this time first of all draw the structure of propanal. So let's draw the structure of propanal. C double bond O. One side it is bonded with H, on the other side it is bonded with CH2 CH3. Now draw the structure of ethanol facing alpha hydrogens towards this side. So this is H, C, H, H, C double bond O, H. Now remove water molecule. Now remove oxygen from propanal and alpha hydrogens from ethanol. Now draw the product of this reaction. So here you will get CH3, CH2, CH, double bond will be formed with this carbon and here you will get CH and here it is bonded with C double bond OH. So this is alpha beta unsaturated aldehyde. So this is the fourth product of the cross aldol condensation between propanol and ethanol. Now write the IUPAC name of these products. First of all, number the chain. So we will start numbering from here 1, 2, 3 and 4. As it contains 4 carbon long chain, parent name will be but. Double bond starts from second carbon. So here we will write 2 in and it contains aldehyde functional group. So here we will write Al. So this is but 2 in al. Now write the name of second product. First of all, select the longest carbon chain. So this is the longest carbon chain and it contains 5 carbon. Now number the chain 1, 2, 3, 4 and this is 5. There is one methyl substituent bonded to second carbon and double bond also starts from the second carbon. So the name of this molecule will be 2-methyl. Now write the name of parent. As it contains 5 carbon, parent will be pent. Double bond starts from second carbon. So here you will write 2 in. As it contains aldehyde functional group, we will write Al. So 2-methyl pent 2 in al. Now write the name of third product. First of all, select the longest carbon chain. So this is the longest carbon chain and it contains 5 carbon. Now number the chain 1, 2, 3 and this is 4 carbon. There is one methyl substituent bonded to second carbon. So the name of this molecule will be 2-methyl but 2 in I. Now write the name of fourth product. First of all, select the longest carbon chain and this longest carbon chain contains 5 carbons. Now number the chain 1, 2, 3, 4 and 5. As it contains 5 carbon, the parent name will be pent. Double bond starts from second carbon, so 2 in I. So that's how you will get 4 different products by the cross aldol condensation. Now let's read from the book. Ketones can also be used as one component in the cross aldol reaction. So this is the example. This is benzaldehyde. When it reacts with acetophenone in presence of dilute alkali, it gives cross aldol product. The name of this cross aldol product is benzyl acetophenone. Now let's understand how this reaction takes place. When aldehyde and ketone both are present in the molecule, so this is C double bond O H. This is aldehyde functional group and this is ketone functional group. When they both are present in the molecule, which will act as a nucleophile and which act as an electrophile? We know aldehydes are more reactive towards electrophilic addition reaction. So ketone will act as a nucleophile, means you have to remove alpha hydrogens from the ketone. So we need to remove alpha hydrogens from ketone, and that ketone will act as a nucleophile. So here, first of all, draw the structure of acetophenone. So this is the benzene ring, and here carbonyl carbon is there, and here it is bonded with CH3. When it reacts with dilute alkali, so this is dilute NaOH. This dilute NaOH will abstract alpha hydrogen from this ketone molecule, and the bonding pair of electron will move at alpha carbon. So here you will get your nucleophile. This is phenyl group. It is bonded to carbonyl carbon, and here you will get CH2, and this carbon carries negative charge. So now this molecule will act as a nucleophile. Now this nucleophile will attack on benzaldehyde. Now draw the structure of benzaldehyde. So this is benzaldehyde, C double bond OH. This is benzaldehyde. And we know this carbonyl carbon is electron deficient carbon. So this nucleophile will attack on this carbonyl carbon and move these pi electrons to oxygen. Now write down the product of this reaction. So here this is the benzene ring. Here it is bonded with carbonyl carbon, and this CH2 will get attached to the carbonyl carbon of benzaldehyde. So now draw the structure of rest of the molecule. So this is C. Here it is bonded with oxygen. Oxygen carries negative charge. One side it is bonded with H, and on the other side it is bonded with benzene. Now when this molecule abstracts hydrogen from the reaction medium, so here you will get beta hydroxy ketone. This is CH2. Here this is COH, and here there is a benzene ring. So this is beta hydroxy aldehyde. Now when you remove water molecule from this molecule, so OH will be removed from this carbon and H will be removed from this carbon. So here double bond will be formed between these two carbons, and you will get the aldol condensation product. C double bond O CH. Now double bond will be formed between these two carbons. So here this is C H, and here this is bonded with benzene. So this is the benzyl acetophenone. Now write down the name of this molecule. First of all, select the longest carbon chain. So here it is 3 carbon long chain, and there are 2 phenyl groups bonded at both the ends. Now number the chain. So here we have to start numbering from the carbonyl carbon 1, 2 and 3. At first and third position phenyl group is bonded. So here we will write 1, 3 diphenyl. Parent contains 3 carbons, so parent name will be prop. Double bond starts from second carbon, so here we will write 2 ene, and ketone is at first carbon, so here we will write 1 one. So this is the one major product of the reaction. And if you want to get the product by the short trick, I told you earlier, you have to remove alpha hydrogens from ketone. Now write down the product in that way that you can remove alpha hydrogens from ketone. So draw the structure of benzaldehyde first. So this is the benzaldehyde, C double bond O, face O towards the ketone. Now draw the structure of ketone facing alpha hydrogens toward this molecule. So here we have to write CH3. Now here this is carbonyl carbon, and here it is bonded with the benzene ring. Now remove water molecule. Oxygen has to remove from the aldehyde and alpha hydrogens has to remove from the ketone. Now join both the molecules to get the aldol condensation product. So this is phenyl CH. Now you have to draw double bond between these two molecules, and here you have to write CH single bond C double bond O, and here it is bonded with phenyl. In this short trick you will get the same product of the reaction. It also contains 3 carbon. When you start numbering from the carbonyl carbon, this carbon will get 1, 2 and 3. At first and third position phenyl group is there. Double bond starts from second carbon and ketone is at first carbon. So this is the same molecule. Now come to the next reaction. Next reaction is the Cannizzaro reaction. Aldehyde which do not have an alpha hydrogen. In case of aldol, alpha hydrogen was required. But in case of Cannizzaro reaction, alpha hydrogen is not required at all. It undergoes self-oxidation and reduction, means disproportionation reaction, on heating with concentrated alkali. In case of aldol condensation, dilute alkali was required and alpha hydrogens were required. But in case of Cannizzaro, absence of alpha hydrogen and concentrated alkali is required. In this reaction, one molecule of aldehyde is reduced to alcohol while another get oxidized to carboxylic acid salt. So when you take the example of formaldehyde, in formaldehyde there is no alpha hydrogens because there is no alpha carbon. So when two molecules of formaldehyde react with a concentrated KOH, concentrated alkali, one of the formaldehyde molecule get reduced to methanol and the another molecule get oxidized to potassium formate. It is the potassium salt of formic acid. And there is another example, benzaldehyde. In benzaldehyde, the carbon to which this aldehyde functional group is bonded is the alpha carbon and it doesn't contain any hydrogen. So it can undergo Cannizzaro reaction with a concentrated NaOH. One of the benzaldehyde get reduced to benzyl alcohol and one of the benzaldehyde get oxidized to benzoic acid. But because of the presence of strong base NaOH, it converts into sodium salt of benzoic acid. The name of sodium salt of benzoic acid is sodium benzoate. Now come to the next reaction. Electrophilic substitution reaction. Aromatic aldehyde and ketones undergo electrophilic substitution reaction in which carbonyl group act as a deactivating and meta-directing group. Now let's draw the structure of benzaldehyde. So here this is the benzene ring and here it is bonded with carbon. Carbon is bonded with oxygen and here is hydrogen. In this benzaldehyde, electronegative oxygen is present at the distance. It is bonded through the another atom. That's why it will withdraw electron density from the ortho and para positions. As it withdraw electron density from ortho and para position from minus m effect, it reduces the electron density at ortho and para position. That's how comparatively it increases the electron density at meta positions. So that's why it is meta directing. and it directs the coming electrophile at meta positions. When it reacts with the nitrating mixture, which is the combination of HNO3 and H2SO4, nitro group will get attached at meta position, and here we will get meta-nitro-benzaldehyde. Now come to the uses of aldehyde and ketones. So let's read from the book. In chemical industry, aldehyde and ketones are used as a solvent, starting material and reagents for the synthesis of other products. Formaldehyde is well known formalin solution used to preserve biological specimen and prepare bakelite, a phenol formaldehyde resin, urea formaldehyde glues and other polymeric products. Acetaldehyde is used primarily as a starting material in the manufacturing of acetic acid, ethyl acetate, vinyl acetate, polymers and drugs. Benzaldehyde is used in the perfumery and in dye industries. Acetone and ethyl methyl ketones are common industrial solvent. Many aldehyde and ketones, for example butyraldehyde, vanillin, acetophenone, camphor, etc., are well known for their odor and flavor. In the next video of this chapter, we will discuss carboxylic acid.